All
All
right.
right.
So starting with number six, let's kind of take a look at how we could approach this. Um, the key idea that we talked about on Thursday was that we wanted to get the absolute value by itself, meaning I only wanted this part, right? Including the absolute value bars. That's what I want by itself. So everything else we need to get rid of. And so one of the biggest mistakes I see with a problem like this is that you're so tempted to think about this as being a subtraction, right? 9 minus 4. But if you think about it, there's two separate things happening. The first thing that's happening actually is that there's a product of 4 times the absolute value. And then there seems to be a 9 in front of that, right? So it's actually a product of -4, right? It's -4 times the absolute value. And then there's a positive 9 in front of that, right? So typically what we would want to do here, instead of subtracting 9 minus 4, which is the common mistake, is to first get rid of the 9, right? You want to get rid of the 9 by subtracting 9 from both sides first, okay? That's going to allow you to cancel out the 9. And then what you can do is bring down the -4 times the absolute value of c plus 10, which will equal, in this case, -24. Right. Okay. So then from here, what we want to do is now get rid of the -4, right? Since it's a product of -4 times the absolute value, what we would do is divide by -4 to both sides, right? So the -4 cancel, and now you can bring down the absolute value of c plus 10, which would be equal to 6, right? So the -24 divided by -4, that becomes a positive. Now we're in good shape, because when the absolute value is by itself and it equals a positive, this is when it's possible to get solutions from it, right? We had examples earlier before where we had absolute value equals a negative, and we saw that that was just not possible, right? We get no real solutions. So then in this case, if my absolute value, or the absolute value of c plus 10 is equal to 6, we can move forward and we can split this into the two equations. So the first one, remember, is the original. It's c plus 10, which is going to equal 6, right? We change nothing about the equation except for the fact that we drop the absolute values, so we don't bring it down. And then the second equation is very similar. We keep c plus 10. I don't change anything about the inside of the absolute value. And now it's equal to -6, right? So we set it equal to the inverse. Now we just solve. So first we subtract 10 from both sides. So c will equal -4. And then on the other side, the other equation, will subtract 10 again, but this time c will equal -16. Right, so now we have found two solutions, one -4, the other -16, that would satisfy this absolute value equation. Okay, it's always good practice to go back and check, right? And you guys know how to check at this point. You would just take your solution and you go back and plug it in for c. You could do the same thing with -16 and plug it in for c. All right, so that's just good practice to check your work, to make sure that whatever it is that you found was actually a good result. All right, but in this case, I know that our solutions were correct because the absolute value equaled a positive in the first place. So then I knew I was able to split the equations apart. All right, so that's number 6. Any questions about this so far? All right, so again, the most common mistake, and you're going to feel super tempted to want to subtract 9 minus 4, right? Remember that let me show you what another version of the same equation, essentially what it is. This equation is also the same thing as this. Right? And you can see there how if you saw the positive 9 on the back, right, behind the absolute value, you would know right away, like, yep, I got to subtract 9. But by putting it in the front, it makes it slightly tricky, right? It makes you think like I got to subtract 9 minus 4, that's 5, and then it's 5 times the absolute value, right? And then it seems like that would be the correct thing to do. And so that's why it's always good to then double check your work in the event that you did take that route and you got some value. If you went back to and plugged it, you can move it so that it's in the back. And then you can see how it's much easier to subtract the 9 instead. Okay. So that's just like a little tip right there. All right. Let's move on to number 7. Number 7 is a special case. It is a much more challenging type of absolute value equation. So we'll take a look at this. All right. So the reason why this one is a special case is because you have variables inside of the absolute value and you have variables outside of the absolute value. In every other problem that we worked on, the variable only existed inside the absolute value. And on the outside was just a bunch of constants, right? They were just values, just numbers, no variables. So in this case, I have my absolute value of 8 minus 2n minus 5n on the outside, and then that's equal to n plus 2, okay? So first of all, the goal always is to get the absolute value by itself, all right? So in this case, my goal is I want all of this to be by itself on the left side, which means I would have to get rid of the negative 5n. I'd have to move it to the right side. So first, we're going to add 5n. Okay, so the negative 5n plus 5n, 0 pair, that cancels out. And then what's nice about it is now that we have this absolute value of 8 minus 2n by itself, okay, now it's equal to n plus 5n, that's 6n plus 2. Okay, all right. When the absolute value is now by itself on the left side, you're going to treat it like you would before, right? You're going to go ahead and split the equation. You're going to create 2 equations, okay? Now, the first one is very simple. You're just going to, again, copy everything without absolute value, all right? So your first equation is going to become 8 minus 2n, right? It's the inside of the absolute value, is equal to 6n plus 2, okay? Right, everything's the same except the absolute value, we just drop them, all right? Now the second equation, right? Think about what we would normally have done, right? We would have brought down the 8 minus 2n, and then it would have equaled the negative, right? The negative or the inverse of whatever was on the other side of that equal sign. But since this time we have an expression, 6n plus 2, right? We're going to negate, or we're going to give the inverse of the entire expression, right? So it's going to be equal to the negative of the entire thing, 6n plus 2. Right? So you see, I wrapped it in parentheses, I multiplied it by a negative to ensure that I'm setting it equal to the negative of the entire thing, right? So 1 is my original. The second equation will be equal to the negative of 6n plus 2. Okay, does that make sense so far? All right, we got some feedback. Yes. Okay. Right. So it's the same thing that we do in the other equations. It's just that before it was just a number. So it was easy to just give the opposite of that number. Now, since it's the whole expression, we give the negative of the whole expression. Right. So 6n plus 2 on the left side, and then the negative of the entire 6n plus 2. Okay. So very important that you put parentheses and then the negative on the outside. All right. So now from here, we can just solve. Okay. We can solve. So we can add 2n to both sides, and we'll get 8 is equal to 8n plus 2, right? We want to solve this by subtracting 2. So we get 8n is equal to 6, okay? We divide both sides by 8. That's all right. We're going to get n is equal to 6 over 8, and here we can reduce that fraction. 6 and 8 can both be divided by 2, so this reduces into 3 over 4. All right. So far, n equals 3 over 4. That's one of my solutions, okay? Now let's solve the second one. all right? When we solve the second one, the first thing you'd want to do is distribute that negative, right? You want to remember that this is like having a -1 here. So you distribute -1, and here you can say you have 8 minus 2n equal to -6n minus 2. Okay, so now let's solve, right? I'm going to go ahead and add 6n to both sides so that I end up with a positive n value here, right? A positive coefficient. So this becomes a 0 pair. We get 8 plus, that would be positive 4n is equal to -2. Okay, so from here, what we do next, let's subtract the 8. So 4n is equal to -10. And then we want to divide both sides by 4. So n is equal to negative. Here we want to reduce the fraction, right? We can divide both top and bottom by 2. So we get -5/2. Okay. All right. Now, in most cases, I would say, okay, it looks like we're done. We have our two solutions. But one of the things that we need to be extremely careful of when we have one of these absolute value equations, and the reason why it's a special case, is not only do you have to treat what it equals to kind of uniquely, but when you get your two solutions, you have to test them. You have to test them because a lot of times when we have one of these types of equations, one of the solutions ends up being kind of like a false one. Like we get this second answer that probably never should have been. All right. And it's just due to the nature of the way the absolute value works sometimes. Okay. So special case, one of the things is check for what we call extraneous solutions. Okay, and extraneous solutions is exactly that. It's like an extra solution. It's an extra solution that never should have been. Okay, so then we have to go back and do a lot of like the kind of the labor here to figure out which one of these is the correct one, which one of these is the extraneous one. All right, so let's go ahead and do that. We can do that right here in this inequality, or this, I'm sorry, not inequality, in this absolute value equation right here. Okay, you can also take it back into the very original up here, but this one seems like it's a little bit more work to have to plug in your value into 3 different locations instead of just 2 different locations in this equation here. Okay, so we're going to do the checking process, and we have to do it, right? We have to do it whenever the variable is on the outside of the absolute value as well as the inside, all right? So in this scenario, we have to check. So I'm going to call this a mandatory check. All right, so we have 8 minus 2n equal to 6n plus 2. So we're going to first plug in 3 over 4. So here we have 8 minus 2 times 3 over 4 equal to 6 times 3 over 4 plus 2. Okay, so we plug it in for the n value, and then we just have to check that whatever we get inside absolute value will equal whatever is on the outside of the absolute value. All right, so let's clean this up a little bit. Inside the absolute value, you have to clean up whatever's on the inside of the absolute value first before you can take the absolute value. So you have to keep the absolute values for now, just clean it up, right? So you have 8 minus, this would be 2 over 1 times 3 over 4. So that's eventually going to become 6 over 4, okay? Equal to, similar thing on the outside, right? That's a 6 over 1 times 3 over 4. So that's going to be 18 over 4, and then plus 2. All right, so now let's clean up. We have 8 minus 6 over 4. This part here, okay, since they don't have common denominators and the 8 only has a denominator of 1, we would have to make sure that they have common denominators. So here it requires us to multiply the top and bottom by 4. Let me actually do that with a little more space. Okay, so we want a common denominator, so we're going to multiply this one by 4 over 4. All right, that's going to give us absolute value of 32 over 4 minus 6 over 4. Okay, and then on the outside, similar idea, right? Because I have 18 over 4, I want to make sure that I have common denominators on the outside as well. So I'm going to have to multiply this 2, which again is like a 2 over 1. We multiply this one by 4 over 4 as well, so that the denominators match. That's going to give us plus 8 over 4. All right. So let's go ahead and clean it up now. Finally, we can say this 32 minus 6 would be 26 over 4, right? Absolute value of 26 over 4 equal to, and then on the outside, now we can add these numerators. 18 plus 8 is 26, and then the denominator is a 4, right? So if you take the absolute value of 26 over 4, that's going to be 26 over 4, right? So this one seems like it checks out. So we have a solution, 3 over 4, which is valid, right? So when it is valid, you want to go ahead and box it, right? So only when you've checked that it's valid, then you can box it. All right, that's how you've secured, and you can say, like, now I know that this for sure is a solution. All right, that's only one of the solutions, unfortunately. Right now we have to check the second one. Okay, so these become a lot of work because of the checking, and then if you have fractions, you have to deal with the fractions, right? There is no fraction buster possibility here because you're not solving an equation. You're just substituting and then you're simplifying, right? So we can't use fraction buster to make anything really that much easier for ourselves right now. All right, so now let's check the second one. Okay, let's check the second one. I'll do this in a different color. So we're checking once again in the same equation. What we want to do here is plug in negative 5 over 2. All right, let's see if this works out for us. All right, so we have absolute value of 8 minus 2 times negative 5 over 2 inside absolute value is equal to 6 times negative 5 over 2 plus 2. Okay, I think this one might be a little less work because it looks like the 2's are going to be, you can reduce them. All right, so we have absolute value of, oops, wrong color. Absolute value of 8, right? And then here, if you multiply through, that's negative 2 times negative 5, so that's a positive 10, and positive 10 over 2. So that's nice, right? That's going to end up simplifying into a whole number, okay? Equal to, and then same thing on the outside, right? That's a 6 over 1. You distribute in, that's going to be a negative 30 over 2 plus 2, okay? So let's see if we get the same thing on the inside of the absolute value as equal to what's on the outside of the absolute value. So this ends up being absolute value of 8 plus 5 equal to, we can reduce this one. That's also going to be negative 15 plus 2. And here's what we got, right? We can add up the inside of the absolute value first, right? We always clean up what's on the inside first. So we get absolute value of 13 is equal to, on the outside, that's negative 15 plus 2, that's negative 13, right? So ultimately, absolute value of 13 becomes 13, but that's not equal to negative 13, right? And this is why it's necessary to check, because one of the solutions was giving us a false statement, right? You can see that 13 does not equal negative 13. Therefore, the solution that we use, negative 5 over 2, was not a valid solution. This was the extraneous solution, right? So really, we only had one solution to the absolute value equation, and it was 3 over 4, right? Negative 5 over 2, somehow it snuck in there algebraically, but when we check it, it doesn't give us a true statement, right? Because 13 is not equal to negative 13, okay? So special case, a lot of work, right? You have to solve, and then on top of that, you have to check. The other ones that don't have the variables on the outside of the absolute value, those you don't need to check all the time. It's good to check to make sure your work is right, but it's not a mandatory check. The only time it's a mandatory check is when you have the situation that we had up here, where you have one variable inside and then one variable outside. Right? One variable is inside the absolute value, one variable is outside the absolute value. And that's when it's mandatory that when you find your solutions, you go back and check. Okay. All right. Any questions about this so far? Okay. All right. So I would like for you to try number 2. You don't have to do it on the Nearpod because I just realized how much work it is. So I'd rather you keep all this work in your notebook, right? And not spend time trying to write all this out with the Nearpod, all that stuff. Okay, so don't worry about the Nearpod. Focus here. Work on this example right now. I'm going to give you about 5 minutes. Okay, I won't be able to really see what you're doing, but you can chat with me and you can ask me if you think, if the 2 solutions you got, or you can tell me I got this one as extraneous, I got this one as real, and then we can kind of chat at least about what you're getting. All right. So go ahead and work on that. I'll put a little timer up for about 5 minutes to give you an idea. Then we'll come back and then we'll go over the problem. Okay. So go ahead and try number 2, kind of like unofficially without the Nearpod. Just do it on your paper right now. Okay. Which will equal x plus 1, right? So if you got up to that point, that's good. Okay. Now from here, this is the part where since the absolute value is by itself, we can go ahead and split this into the 2 separate equations. So we can bring down the original without the absolute value, which gives us 3x plus 9 is equal to x plus 1. And then we would need to bring down the kind of inverse one, right? We keep 3x plus 9 the same, right? The inside of the absolute value will never change, but on the outside, it's going to equal the negative of x plus 1. All right, so let's go through, let's solve. All right, so first, let's subtract x here. That gives us 2x plus 9 equal to 1, right? Then we can go ahead and subtract 9 from both sides. 2x equals negative 8. And then we would divide both sides by 2. So x equals negative 4. All right, don't box it yet because we have to check. This is a mandatory check problem. So I'm not going to box anything until I know it's a for real solution. Okay. Now the other one, distribute the negative. So we get 3x plus 9 is equal to negative x minus 1. And now let's see what we can do. Let's add x. That's going to give us positive 4x plus 9 equal to, this cancels. So then this is equal to negative 1. All right, now we can just replying. Let me go ahead here and subtract 9. So we get 4x is equal to negative 10. Okay, so now let's divide both sides by 4. And then x will equal negative. Here we divide both top and bottom by 2, right? Okay, and once again, don't box, right? Let's see what we can get after we check. All right, so on my first check here, we're gonna check x equals negative 4. So inside the absolute values, we'll have 3 times negative 4 plus 9, and then that will equal negative 4 plus 1. Okay, all right. I already know there's gonna be an issue. Here's why. Look at what it's gonna equal to out here. Negative 3. right? So regardless of what we end up doing on this side, that's not going to be possible, right? The absolute value of whatever is inside will never equal a -3, right? Let's just keep going just so I can show you. -12 here, 3 times -4 is -12, plus 9. So then what you get on the inside, right? You're still working on the inside, cleaning this up first. You're going to get the absolute value of -3, okay? However, absolute value of -3 becomes +3, and 3 does not equal -3. That's a false, right? So what do we know about -4? -4 is extraneous. But do you see how we knew that already just by knowing what the outside is equal to? When the outside of the absolute value equals negative, you can already tell that this is going to be extraneous, because no matter what, the inside of the absolute value is going to generate a positive number, and that positive number is clearly not equal to the negative number on the outside, right? Same thing kind of happens with the next number. Watch this. Let's check -5/2. Okay, so now we're checking the second solution. So we have 3 times -5/2 plus 9 inside absolute value, and then this will equal -5/2 plus 1. All right, this is one of those times when decimals are probably a little bit easier. I'm just going to do the outside. Watch this. -5/2 is like -2.5 plus 1. So now -2.5 plus 1, that's equal to -1.5. And I already know that -5/2 is bogus. It's extraneous, right? Because regardless of what it gives us on the inside, it's not going to equal negative on the outside, right? There's no way that we're going to be able to get this as a possibility, right? But just in case, let's just clean it up, right? So then this is going to give us -15. Once again, just for the sake of simplicity, let's just go ahead and turn that into a decimal. So that becomes -7.5 plus 9. And then if we were to clean that up, we would get the absolute value of -1.5 equal to -1.5, right? But we know that then the absolute value of -1.5 turns this into a +1.5, and that is not equal to -1.5. So we actually ran into a pretty unique question here where both of the solutions that we got were extraneous. Right, so you want to go back and you want to label each solution. If it's extraneous, you want to label it. Okay, and there it is. Let me see real quick. Oh, you're right. You're right. I'm sorry. This is actually a positive. No, you're right. I missed that. Either way, it's an extraneous solution because absolute value of +1.5 is still 1.5. Thanks for catching that. Right. But do you see from here, absolute value of this number is still a positive. And that +1.5 is not equal to -1.5. So it's still the same thing, right? I did make a mistake there. But it doesn't change our overarching solution that -5/2 was extraneous. Okay. So these are definitely the types to look out for the most. They can be the most challenging and they can involve the most amount of work. However, it's critical that you check, because the common mistake here is that you don't check, right? So you get two solutions and you never know which one is real, which one's extraneous. And sometimes you get two extraneous ones, right? So that's shocking. Okay. Any questions before we go for today? I think I'm over like by 3 minutes. But are there any questions?